So my name is Sesh, I'm Senior Product Manager. So we'll talk about the visibility into the virtual workloads and the virtual networks. So this includes the Gigamon, the GigaVUE Fabric Manager, as well as the VM appliance, as well as what we've done with the NSX integration as well. So this is the agenda. We'll quickly skip over this. And then we'll also talk about OpenStack integration, some of our architectural diagrams as to what we think a solution would look like in the OpenStack world. And then we'll do some demos around that. So here's your typical infrastructure looks like. Here you have your the visibility fabric with the applications, your server farm, your virtual servers, and your hypervisor with the VMware vCenter managing the hypervisor themselves. The Fabric Manager right now also integrates with the GigaVUE, the hardware platforms, and the GigaSmart operations that Noam showed. But we also do integration with VMware vCenter, both reads and writes. We get good inventory of the VMware vCenter, including the vSwitches. We also deploy our VM appliances through the VMware vCenters on APIs. Again, what's GigaVUE Fabric Manager? We talked about this being a single pane of glass that is going to be a sort of a entry point into configuring the Gigamon visibility fabric architecture. Again, it has a single pane of glass for both the physical as well as the virtual assets, again, being for the hardware platforms as well as the VM appliances. Again, have at a glance node level dashboards, the top ends, for example, at a node level with some analytics around what ports have errors, what are the drop packets, and so on. So I'll quickly show that in a demo. Then port throughput and historical trend analysis. This is an area where we're investing heavily. Right now, we have some analytics, but we want to do more with respect to not just ports, but also traffic-based, rule-based counters as well going forward. Again, the configuration, whatever we saw from a node-level configuration, we could do it at a single pane of glass from the Fabric Manager for all the nodes in the cluster or the visibility fabric itself. Upgrades, firmware upgrades, event processing, configuration backups. Again, your classical NMS level functions that are things that you need to do for managing the visibility fabric. The RBAC and the AAA services for operations. Again, tie into your TACACS, radius servers, and so on. And then finally, the automation for the virtual workloads. As these VMs are moving around, you have all your VM appliances in your network, and you want to make sure that the automation is done seamlessly without user intervention. And this provides the infrastructure to do that.
Fabric Manager is optional, right? You don't need Fabric Manager?
For the physical infrastructure, you could go to single node and do it. Okay. But for a virtual infrastructure, because it's the single pane of glass that's looking at all the VM appliances, right, is the point to deploy the VM appliances as well as move the VMs around, or move the policies for the VMs around. You need the Fabric Manager for it.
Okay.
But but still, as your visibility fabric grows, as there are more clusters in the visibility fabric, we think Fabric Manager can provide a holistic view of your entire infrastructure for the visibility fabric. So let me do a quick demo of the Fabric Manager. So here are 3 nodes that we have discovered, both our H-series platforms as well as a couple of the tap and axe elements as well. Again, if you want to look at each node, here's a sort of node level view of it, the physical element itself, and then some port level analytics, what ports are down, which ports have packet drops, what are some of the utilization, the top 20 utilization on a per node basis or a per cluster basis. We also have, this is the physical layer, of course, and here is the virtual. We do create the map, the VMaps or the policy monitoring rules for the virtual infrastructure. So this is a single pane of glass for that. Again, don't want to dwell too deep into this, but here are all our notifications, for example, which notifications generate which events. We have events based on all the events that we are receiving from both the vCenter that we integrate with or the nodes that we are managing as well. All your events coming in here. And then some authentication that I talked about in the FM users, the AAA radius and TACACS plus. So as you can see, it is a single pane of glass for all our assets that we manage within the visibility fabric. And I will quickly switch over. When I'll come back to this, the virtual demo a little bit later, and then we can dig a little bit deeper into this. Oh, I do want to show one other quick thing here is, from your ports tab, you see all the ports that are being discovered on the cluster. The traffic maps themselves that have been configured. Again, GNOME showed from a node level perspective, but here is from a entire for the same node, but from Fabric Manager. Again, you can configure them, do all the GigaSmart operations and applications, if you will. Okay. Let's switch back into the. All right, so visibility into the virtualized workload. So why is this a challenge, right? As all of you know, there's a lot of the servers are moving, a lot of the applications are moving into the virtual environments. At recent VMworld, out of the 3,000 odd people that we spoke to or we met at the booth, I would say most of the customers were 80 to 90% virtualized already, and they have a 12 to 18-month projection to go 100%, which means a lot of the traffic is east-west. In this case, within the hypervisor, or the first hop, if you will, within the rack, for example, or within the Blade server in the UCS, and Blade switches also have a lot of the interconnects going on within the Blade server. So how do you get visibility into that traffic? So what we have is a unique solution that will help get that visibility and correlate with the physical infrastructure monitoring that you're already doing. Now, what happens, for example, if you have a server, you virtualize it, there's a lot of traffic going on within the vSwitch. What happens if something goes wrong? How do you monitor that? Right? So what we believe, the physical monitoring tools don't have access to that traffic. They don't know what's going on. It's a critical part of the organization. The applications are running there, and you want to see what's going on there. A compromised VM, malware, whatever it is, could affect, and as the VMs migrate, could affect both the servers as well as the application. And network virtualization itself adds a layer of obfuscation. So how do you get visibility into those, the VXLAN traffic, if you will, as well? And then the operational model between the server and the network admins, how do you help them?
So this is obviously very useful for the overlay portion. How about visibility within a single hypervisor?
Yes, this is a single hypervisor. So in this case, for example, what the picture I've drawn here is this, I don't know, let's see if I can point it here. This is within the hypervisor. It's not even going out.
Okay.
Right, so we do, the fact that we can have a when I walk through the GigaVUE-VM solution, since we are a virtual appliance sitting here, we can get this traffic out to the hardware for the tools to get it.
Okay.
So this has not, again, remember, this traffic hasn't hit the wire yet.
Right, I'm just curious how you're capturing that, traffic.
So so let me walk through that and I'll come back and answer if you don't mind.
Get to it, that's fine.
So here's our value solutions, right? I mean, think of it as your top of the rack switch, top of the rack servers, top of the rack switches connecting to our platforms here, and your hypervisor running on these servers, or blade servers, if you will, or top of the tar servers. And you have your connection, 40 gig connections into our visibility fabric nodes. What we do is drop a GigaVUE-VM into that server. We support VDS as well as Nexus 1 kV as well as virtual standard switch. So we actually do port mirrors on the vSwitch itself, get it into our appliance, and then do traffic slicing. So
what, like RSpan?
It's VDS port mirrors. I mean, their port mirroring technology.
Are you asking how to get it off of their VM or to the VM?
No, to the VM.
Yeah, port mirrors.
Yeah, the port mirrors sessions. Okay. So this is a GigaVUE-VM, is a lightweight footprint appliance. It's a guest OS sitting on the hypervisor. It has some level of flow mapping that we already have in our physical appliance, light footprint appliance. We also filter on the virtual machines, VMAP, VMs, VNICs. For example, if you want to go into that level of granularity, filter specific applications, HTTP ports or TCP ports, any specific ports that you want to.
This is what I like, actually. A lot of solutions, you'll just do a span to a virtual appliance. It gets everything.
Right.
But here you can just say only filter this flow out to send back upstream to the.
Yes, that's the best part. So again, Thank you for you're making my points. Yeah, so exactly. So you can get it in instead of sending it out again on the wire. You can do some level of analysis.
Yeah, that filtering is done in the VM basically. You have rules pushed down to the VM that say I don't want to copy, for instance, the VXLAN header because that's useless or something like that.
Right. I mean, for example, if it's an Exchange application or if it's a HTTP application and you just want to monitor all the HTTP servers, or VDI, for example, if you want to monitor those VDI VMs.
And that'd be an interesting place to do the stuff we were talking about before with application level inspection. You could sort of cache in a very small way, segments essentially, so that you can build a better, bigger picture of the application flows that are happening, and then copy that, in some intelligent way. Would need to have actually a lot of resources to do that.
I guess it's that balance, right? Is how much processing do you do at that point versus pulling it back in?
Yeah.
Well, one other thing which is important to highlight is that we're seeing more and more organizations wanting to move to virtualization and wanting to virtualize some of their appliances that they're using. And the wrong way to do this would be to take every single one of them and make it co-resident with the host, and that will end up putting a lot of load on that actual host, right? So the value here is that we can provide a centralized point for data capture and then allow the various tools to actually have access to the data, and that's a key value prop that should not be lost.
So essentially, one of your little VMs per host because it's light,
right?
Exactly.
Instead of piping everything back using ERSpan or something like that.
Exactly. I mean, also think about it, right? I mean, you may not want all the traffic out. You want to have some level of filter before it hits the wire,
right?
And that's where you can do this.
It's a representation of just about any argument for scale out. But the key is how do you manage it? And it sounds like you guys have a pretty good handle on it. I don't know that we've seen much about it, but
yeah, it's ramping up. It's a big high ramp. We're seeing a lot of organizations scale up to a lot more servers.
Yeah.
Right, and they have their monitoring tools in the physical, and they're moving their applications into the virtual. They want that same level of visibility, and this actually solves that use case.
Does the VM send it out in real time, or does it sort of hold on?
No, right, as soon as it gets. As soon as it's sliced, as soon as the analysis is done, it sends out. There's no buffering.
And what do you see as the most common deployment there? Do you try to see customers dedicate NICs for the servers? Because again, it's similar to an ERSpan, right? And so large environments.
So I would say I've spoken to customers who want all the traffic come out, right? They don't want to do any analysis. OpenAll, for example, right? They're using their existing NICs, not really dedicating a separate NIC for it, because the servers are not those NICs are not fully utilized, so they can use that bandwidth. Some have actually looked for specific applications, and the VDI use cases are common, where they want to specifically look for the VDI traffic alone. It's a gamut. It's not just narrowed down to a specific use case. But the ask is get us that traffic, right, for us to do the analysis.
I didn't understand. On the filtering scenario here, are you telling the vSwitch to only send you certain traffic?
No, or we get everything.
You're getting everything from the vSwitch.
And then the vSwitch our appliance does the filtering on the specific traffic that we want, that the customer wants to get it out.
I mean, certainly you could ask for only some traffic from the vSwitch, I would imagine.
I think vSwitch gives us everything. vSwitch, you can...
Well, I mean, if it's an OpenFlow vSwitch, for example, you could say,
Yeah, we can control it some more and get it sliced a little bit further.
Okay, but you're receiving everything and then filtering.
Right.
Okay, I might have missed something with this. When you deploy the VM, and the VM then creates like records or whatever, do you then push the traffic from the VM up to the tap infrastructure and use
right, so let me build a slice.
The production network for that.
Right, so I think I'll slightly, this Gigamon tunnel that we create between the VM itself over the physical infrastructure, whatever is running, to the physical hardware here, right? That's where we are creating that traffic flow.
So it's kind of like ERSpan, but it's coming out of the hypervisor already filtered and aggregated.
Right.
On the production NICs.
On the production NICs, yeah.
Right, okay.
Yeah.
Right. It's if your question was, is something being funneled into the physical tap? No.
Yeah, I was wondering whether the tap infrastructure was used as a transit network for the information coming from the VM. So it goes through the production network and then enters somewhere. Then you've got an in-band network attached to the production network as well, right?
This port, oops, let me scroll.
So I realise it's a bit of a...
That's why it's like ERSpan.
Yeah.
So one of the ports on the physical hardware is actually terminating the tunnel that we create from the GigaVUE-VM. Right, that's going to the production network. We're not using a tapping infrastructure for that. So again, just want to capture the differences between what the lightweight footprint VM appliance does versus all the applications that our physical hardware does. So, so we're not carrying all that into the appliance, so it's very lightweight.
Just to clarify the point, so the Gigamon chassis, the bigger box, connects as an IP endpoint to the network, and that logical port terminates the host.
Right.
So it's not like a spam port that's also collecting data. It's just an IP endpoint.
Yep. It's configured as a tunnel port that actually is terminating the tunnel traffic.
Okay.
So here, oops, again, sorry, I'm skipping forward here a little bit. The wrong. So just want to capture the differences between the lightweight appliance and the heavyweight appliance. So the other thing also is I want to talk about the slice packets. I mean, sometimes, as we mentioned here, you could slice the traffic at the first 200 bytes for your analysis, so you don't need to send the entire traffic out. We could do that when you create those filters and say, slice it only for the first 64 bytes or the first 128 bytes. That's enough for them to analyze the tools. So you can conserve your network backhaul, so you're not getting it all out of the hypervisor itself. The next thing we want to talk about is the visibility in motion. I mean, these VMs are dynamic. I mean, the whole environment is dynamic and agile. So what happens if the VM migrates? You don't want to be recreating those policies. You want to get them seamlessly done without user intervention, because vMotion itself is done through DRS schedulers and so on. So what we do is when a vMotion is initiated, the VM migrates over from the vSwitch to the other hypervisor. With our integration, as an example integration with vCenter, we get the notification and we send the updates. So that policy is now migrated from one appliance to the other.
Oh,
seamlessly.
That raises a good point. So you're basically, when you do the filtering of the VM, you're not pushing down all filters across the board. You're pushing only relevant filters. Right. Excellent.
And this change that happens, it happens with zero intervention from the administrator. That's a key point here.
Right.
So again, the automation of the redeployment of rules that follow the VM across the hypervisors.
So in that case, can you move the GigaVUE-VM, or do you relocate the Gigamon rules into another VM on that host?
The rules are moved. Our assumption is that if you are in a production hypervisor environment, you're going to have monitoring appliances on all the hypervisors. You're just moving the rules around based on where the VM.
So for again a smaller deployment, and it was more ad hoc based, to say I want to, there's an issue, so I want to now move the VM. The moving of that would be manual, right?
Yeah, I mean, so if you look at an environment, the proof of concept case maybe, but in a real environment, these VMs are, you don't know where they're deploying these VMs. They get spawned off.
Well, I'm just saying, it could be unrealistic to think you're going to deploy a VM per hypervisor, realistically.
Right.
Right?
So in this case, we do deploy a VM per hypervisor. That's the case.
But I'm saying that could be unrealistic, given the size of the environment.
The VM footprint is very small.
It's 2 gigs of RAM. So the other thing, the other reason why I bring that up is also because if you are looking for this traffic, if, for example, let's walk through your use case, right? If this GigaVUE-VM wasn't here, but if it is 1 GigaVUE-VM for 10 hypervisors, for example, let's say, then the traffic that needs to be filtered is actually sent over the production network before dropping some of it off, and then only sent that. Only those filters are sent out, right? Only that traffic is sent out. In this case, you're right at the source. You don't want to hit that. You don't want that traffic to hit the wire, so you can do an analysis right there in the hypervisor itself before sending it out.
Sure.
Rather than filtering out everything, rather than getting everything and then dropping most of it that you don't need. That was one of the use cases. Sure.
Also, can you hear me? To add to that, most vSphere environments are obviously cluster-centric. So in production, what we're seeing our customers focus on is deploying our GigaVUE-VMs on all the hosts in a cluster, because it's important if they're using HA or DRS, they don't know where a VM is going to wind up. And if they want visibility to that traffic, they have to guarantee, obviously, that our GigaVUE-VM is on each one of those hosts. So for them, it's not an issue of deploying it, of moving the GigaVUE-VMs around. That's important for them.
Okay. Thanks, Ray.
One more, sorry. I'm curious how you handle the lockstep issue. Like if you have a vMotion event happening, how speedy is that policy reinstantiation? Is it dependent, right? Like is there any way, and this is probably my ignorance of how that interaction takes place, but is there any way that you can actually say, okay, you're trying to do a vMotion, go ahead and copy the RAM, but before you actually make that V live copy, let's instantiate this policy, and okay, now we're good, right? How do you handle that problem?
So as soon as the vMotion takes, let's say depending on how big the VM is and what's moving out, right? Yeah. So once the vMotion is complete is when we get the notification.
Okay.
And then on that notification is when we react.
So there could be some small
delay of time based on how.
That's fine. I mean, I'm sure it's not really that big of a deal, but my main reason for my question was if like you could anticipate that vMotion and maybe instantiate policy in both places, and then once you verify that it's moved, just shut this down. Might help the interaction a little bit.
That's an option.
Okay, cool.
Now, does your level of visibility or the way you interact change if you're using like a distributed vSwitch?
No, the interaction doesn't change. We do support, so on the standard switch, we added support for the standard switch as well. So standard switch doesn't support the port mirrors option itself, so we do have some slight changes for the standard switch versus the distributed switch. But the interaction on how the rules are set up doesn't change.
That's interesting. So how would you do the port mirroring with the standard vSwitch?
So, I can take it. So what we do is we create from the standard switch, we do create a promiscuous mode for the VLAN 4095, get the traffic over, and then do the same level of filtering that we do.
Cool.
That's only for the virtual standard switch.
It's only for standard switch. Yeah, there's no other
So you end up connecting it with a VNIC into each standard vSwitch on the host. Okay.
Right.
So we do support, as Sesh mentioned, the VDS, the Cisco Nexus 1000, and as well as the, if you will, the NSX VDS, because the VDS and NSX is not just the standard VDS. As you know, there's additional kernel components that are added, right? So those three virtual switches we support. We can leverage the port mirroring, the port profiling of those virtual switches on the virtual standard switch because it's the legacy virtual switch, if you will, of VMware. They never implemented port mirroring. So we have to obviously leverage promiscuous mode for that. And all this, though, the configuration for that is done behind the scenes and automatically. So the user doesn't have to do anything. When they create the rules in the Fabric Manager, that's pushed down to each virtual switch. The key here also, though, we have a few customers that are still on virtual standard switches, but all of them are migrating, of course,
the VDS
to VDS. So it was just there for legacy support.
Okay. Key benefits, again, the automated migration of monitoring policies in an agile and dynamic environment. Again, conserve network backhaul by slicing traffic. We talked about the slicing rules. And then the visibility into the intra-host and the inter-host VM traffic. So, well, that is on the VMware environments, other virtual switches, the virtual other hypervisors. What are we looking at the KVM, right? We want to be hypervisor agnostic. We want to look at what KVM and OpenStack support. A lot of the public clouds, a lot of the SP clouds, for example, are moving in that direction. So we want to expand traffic visibility for KVM and the VM traffic on a per VNIC level. Ananda mentioned about our contribution into open source. We are working with the community for a tap as a service to avoid any specific hacks for the Open vSwitch. Right now, we were hoping it will be in the Juno release, but it looks like it might make the Kilo release that's coming up. Again, the interesting thing about this OpenStack integration is you want to integrate into its ecosystem. All the parts of the ecosystem where we need to play in the Horizon portal, the Neutron integration, the Glance repository, because that's how those VMs are going to be loaded onto the hypervisor. So we want to make sure we integrate into that. Again, FM is your GigaVUE Fabric Manager is still your single pane of glass for all your entry points. So we will expose a lot of northbound APIs for the OpenStack ecosystem to plug in. And then also the solution for visibility as a service in the OpenStack cloud. So I'll go through a quick picture of what that will look like. So here's what we envision our solution to look like. The OpenStack controller integrates with the GigaVUE Fabric Manager, and the plugin is controlling the virtual appliances on the hypervisor itself, and then sending the traffic over to the physical nodes to the tools. So a similar picture as before, but now with the OpenStack integration. So this is your Uber or big level, big picture solution, for example. Now, typically, you're going to have a tenant owner who's going to ask a cloud provider for certain services. One of it could be the visibility as a service, for example. and then goes through the OpenStack ecosystem, gets the Nova to create those hypervisors to create those applications, and then OpenStack, and then also asks for the visibility of the service, and then the Gigamon plugin will control these appliances, right? And then the traffic is sent to the tools. Now, again, there are two personas here. For example, the tenant owner versus the cloud admin. So he's going to see some of the traffic through Celometer, whereas the tenant owner might see the traffic through the metering that they get. So this is what we envision the system would look like. And then we've road tested this with some of our large SP customers. It seems to resonate quite well for that picture.
So in this model, how do you use VMs? Sort of multi-tenant on the actual VM itself?
That's exactly the reason why we want to work with the OpenStack community, because it's tenant-based. We don't want leakage of traffic. So we want OpenStack to give us a tap as a service. So when we ask for this tenant, this VM, this VNIC, only give that traffic rather than get everything
supported. What I'm saying
is
if there's multiple tenants that want to tap their traffic, is that it's not a VM per tenant, right?
You could have multiple VMs per tenant.
Good point.
Could have multiple VMs per tenant, though, right?
No, but I mean, if you have like 5 tenants, right, and each tenant wants to use their new task offering, then are you deploying 10, GigaVUE VMs per hypervisor?
No. It'd still be 1 GigaVUE VM, but how we get the traffic out of that, the Open vSwitch, is going to be depending on the tap as a service that the customer asks. And if you're only going to ask for this tenant, then we only get that traffic and analyze it. Again, there's a lot of concern about the tenant leakage or the traffic leakage, and then how we want to, and that's the reason why we want the isolation, and hence working with the community to get that. I mean, there are basic premises already in Open vSwitch with port mirroring. We don't want to use that because that actually has some security issues. So we want to make sure that we get the right implementation in place to avoid any tenant leakage concerns from the customers. Again, so I'll quickly. I have about 5 minutes. So here's a demo setup. So I'll talk through the 2 demo setups quickly. The NSX, again, we have the VNIs that filter on the specific VM traffic. So let me jump over. So again, so here's our physical nodes. The virtual nodes, again, have the port mirrors. I'm sorry, not the port mirrors, the rules themselves on what traffic we are looking at. Quickly, let's look at the system here. This is your virtualization vCenter that we've already discovered. And we use a bulk deploy option where you pick a set of hosts and want to deploy it in a single click. So you don't want to have to go through one host at a time. So we have that option here. We talked about that Gigamon tunnels that you can get the traffic out over the production network. So you configure those. Then once you've got all that configured, you go to your virtual setups or virtual rules, for example, create your rule. What we also have is, for example, I just want to quickly walk through this and show you some interesting things here, is configure applications. So we have some predefined rules that we think are common use cases, right, where customers don't have to go hunt those rules down, hunt those ports down. So we have about 20 odd rules. For example, let's just say web, for example, has HTTP, HTTPS, all the extensions that are already predefined. So it's easier for the customers to create those rules. So I won't go and set it up, but all I'm trying to convey here is the ease of which you can set up your rules for the traffic to be monitored. So what we have done here is a quick, from a single host, we picked a VM, which we are piping it through, getting traffic for a specific destination. And then this is your information where you can slice the traffic down to how many bytes you want. So, so we have it running here. So let me. So anyway, so here's the so this is the Wireshark that's connected off of the hypervisor where the ping traffic for a specific destination is being tracked, and then we get that traffic here. So what I want to quickly show also is our ability to slice the traffic down. Let me try slice it down to 64 bytes here, and then show that the rule gets applied. And then now you should see the traffic sliced down to 64 bytes. So a quick way of rules are applied, and now you're getting the same traffic, but you've sliced it down to 64 bytes in the center. So I think I'll stop there. There's a lot of things I can show, but I think we're right on the top of the time slot, so I'll stop there and then.
You mentioned the OpenStack integration was not primarily, but one of the big reasons was to avoid OVS hacks. You want to elaborate on that a little bit?
So again, so I think he asked the question about, can you get this traffic for a specific tenant? I mean, we could do the port mirror, get everything off of the vSwitch.
Yeah.
But it's possible that customers may not trust us, in this case, to get all the traffic and then slice it only for, and then send that out. So what we are trying to ask OpenStack is, we will ask you for a specific tenant, specific VM, so only give that traffic out to the port mirror sessions rather than give the entire traffic coming out of that VNIC.
Okay.
Right? So you could, I mean, right now there are hooks in place within Open vSwitch to get at the bridge level, for example, to get all the traffic out. But we think that is not a clean solution. We think it actually allows for security concerns with customers.
So if your VM is compromised, then potentially you're seeing multiple tenants' data, right?
Exactly.
Gotcha.
And then tunneling that out is, I mean, we could make a lot of arguments like for it or against it, but we think it's a cleaner to say, let's build it into the OpenStack, Open vSwitch itself, get that as a tap as a service. We'll ask as a service, tenant, VM, VNIC, give me only that traffic. And that way, then after that, we can do our slicing and dicing, whatever.
But it's still the same issue, though, because it's still a common VM, right?
But we're expecting OpenStack. So the more that are built into OpenStack primitives, the better off the solution looks from a security perspective, right? And that's one of the.
We've done one or two things, haven't you? I mean, you've shifted the responsibility to select what VM you want to sniff for, and then if the VM does get compromised, you reduce the footprint of the thing, the visibility anyway.
Right.
So also, I mean, I think I lost the picture here. So if you looked at the picture, the tenant owner, there could be hundreds of tenants. The tenant owner is only going to say, here are my VMs, and I only want visibility into those VMs. Right? He doesn't really want that VM's traffic to be seen by other tenants or other cloud admins or whoever it is. So he wants to be assured that that traffic is the only one that's coming out and monitored, and we're working with the OpenStack.
So would you see that VM having a VNIC in every VX
any networks, for example?
Yeah.
Don't know, what the customers might.
I'm just saying that's a caveat too. Hypothetically, again, if there's 100 tenants, like, does your VM have 100 VNICs?
I don't know. I don't think so.
Right,
I don't think that'll be the case. But it could be that there are. You could have a single logical. Well, you could have a single logical network, and they're all the cloud admin gives them a certain network space, and multiple VMs are actually using that logical network. And then NAT it out, for example. But then if your traffic is going to go through that logical network out, you could technically get all the VM traffic to our appliance. Then our appliance needs to make sure that you're only getting information relevant for that VM. But we think it's better off that OpenStack does that and gives it exactly, from a tenant's perspective, what VM, what traffic to us.
My question was more around the lower level details on the VM. Again, because if you're going to stick to doing one VM per physical host, and if there's, again, lots of tenants, and each tenant just has small virtual machines, so you can pack on a lot of tenants on a single host.
Right.
So, what does that VM look like? Because there are limits. I don't know if they're off the top of my head, but there are limits on the number of VNICs per VMs.
That's true. Oh, we'll test it out. Okay, I think that wraps up my session, and I'll hand it over for a wrap up to Ananda.
Thank you, Sesh. So that was what we had in terms of the prepared slides. We're just watching some of the Twitter feeds. I think one of you, Lindsay, you had a question in terms of not much about enterprise WAN. So
I think it was coming from Bob, actually, that one.
Okay, I'm sorry.
But I am interested as well. So.
Okay, great. So let me address that. Enterprise WAN is actually a very important application and use case where we are installed. And when I talked about remote sites and off-prem, that's exactly what I was talking about, right? So because in branch offices in particular, that's a fairly big pain point. So the solution that we have there is the HP1, which is a compact node that essentially is installed at the remote site. And by the way, when I say remote site, it can actually be something like an oil rig as well, right? So you don't just think about it as a branch office. And the idea here is that because you as an enterprise cannot afford to have tools distributed at every single remote site, you would capture the traffic there, do the necessary transformation right there, and that's a very important point. And then backhaul the traffic, because now we've got to be very sensitive to WAN costs, right? So the key thing here is that, again, even if it's a remote site, we're not looking at a tap and ag solution there, right? We're looking at an intelligent node that's located remotely, which will do the necessary packet transformations and make it much more efficient to backhaul the traffic. You can actually, for example, have a policy that says, you know what, I just want to be doing net flow generation there, right there, and only send the net flow traffic back into the central location.
Grab headers or something
exactly.
like that, right? Okay.
Exactly.
So that's good. That's what I wanted to hear there. So, and then is that then gets tunneled back to the rest of the Gigamon?
That's correct. Typically at your headquarters site.
And can that all then get managed through the same the GigaVUE-FM and all that kind of stuff? So it's still treated as one.
Yep.
Can go as much like enterprise-wide.
Exactly.
The entire fabric. Okay,
exactly.
Cool. Great. Okay. So I want to hear. Thank you.
That's good.
So I'm going to wrap up here and then open it up for other questions. So what you've heard over the last couple of hours is what Gigamon stands for. We're not a tap and ag solution. This is all about traffic intelligence, right? Because as I mentioned before, the job that the customer wants to get done is to get visibility into the infrastructure to solve a specific need. Could be around operational management, could be around security, could be around customer experience management. That's what we're here to solve, right? So while data acquisition, whether it's a VM or a traffic aggregator node in a top-of-rack switch, those are important attributes. Do not forget the fact that the packet transformations, the session-level information, the stateful correlation that we do, that's a very key value of what we do. And when we talk about active visibility, it's about pervasive reach. Doesn't matter where the traffic can originate. I think the last question that you had in terms of a remote enterprise WAN site is spot on. Whether it's a virtual server, doesn't matter. Irrespective of where the traffic comes from, we can capture that, do the necessary transformations before forwarding it over to a central tool. And number two, it's the traffic intelligence, which is very, very important, right? So irrespective of where the traffic is coming from and of what the specific consumer of the information is looking for, we can provide the right information at the right time. We have been increasingly having discussions with many customers. The most recent one was with a large retailer that I had, where they're not just talking about customer experience management and security, but they're now looking at big data feeds that can actually take this traffic feeds and do real-time analysis. So we believe that the potential for this technology is huge, because when you combine the power of intelligence in real time, what you can do with real-time analytics tools is simply massive. With that, I'll wrap up here, open up any questions that you may have, either about today's presentation or anything that we may not have addressed. And by the way, my Twitter handle is @Ananda Rajagopal. If you know how to spell my last name, it's just a juxtaposition of my first and last name.